A very good afternoon, ladies and gentlemen here in the room, ladies and gentlemen at home at our live stream. We have today our yearly event, and we have 5 nominees here in front of the room who are a bit nervous because, first of all, they are, let me say, honored because they were able to nominate themselves for the yearly ACE Award, but this ACE Award will only be handed over to one person. So it's one of the 5 of you, and it will be the jury who, on basis of what you are presenting, on basis of what you have presented already on your posters, come to the final conclusion who will be the winner of the ACE Award 2020. ACE, ladies and gentlemen, is the Automotive Center of Expertise. The Automotive Center of Expertise is an initiative of the 3 universities for applied sciences in the Netherlands who have automotive as a graduation direction. This is Fontys, University of Applied Sciences, HAM, Arnhem-Nijmegen, University of Applied Sciences, and the Rotterdam University of Applied Sciences. And of course, all 3 of them are nervous as well this afternoon because they hope that their candidate will win the ACE Award. And besides that, it is the companies that you have been active at in your graduation work, because ACE is not only having these 3 universities for applied sciences and the branch organizations in the automotive sector, but we have a group of partners, which most of the case is companies, and in some cases it's public institutions, who as a group are, as we call it, the Premier League of the automotive sector. They jointly discuss and debate on the developments in the automotive sector and help in the directions on what education should be given to young professionals in these years, knowing that the coming 45 years, on the basis of this know-how, they will have to fulfill their duty in their full career, and a career lasts longer than 40 years. And ACE is willing, as a type of broker between the industry and the education institutes, also a broker in helping to find good places where you can do your study in the last month of your full bachelor or master program. We try to connect the good companies and the good students, and we try to do that on a very high level. And we have learned that this really helps not only the students to come to a good end result of their study, but also the companies, because if you have done your work okay, and that will be judged this afternoon, then the company where you have done your graduation will be happy with the results and will continue to work on it by implementing the results or whatever they can do with what you have delivered. So this is the top 5. The top 5 of, I don't know the exact number, but more than 100 students. And this top 5 already must feel honored that you are sitting here in the room this afternoon and that you are able to present the results of your study to us, to all of us, not only here in the room, but also on the live stream, but especially to our jury, because they, in the end of the afternoon, will come to the conclusion who will be the winner. This will all be done in a nice program this afternoon, where first the 5 of you will present the results of your study, and after that we will have some presentations of the student teams of the several University of Applied Sciences that are connected to the ACE organizations. And all of that will be explained, and we will be helped through the program this afternoon by my colleague Saskia Lavaux, and I would like to ask her to give the further explanations of what will happen this afternoon and help us through the program of this afternoon and come to the end of the conclusions in the end of the afternoon when we go to the drinks here, and you're able at home to take your own drink as well, of course. Saskia.
Thank you, Kees, for your lovely introduction. So I will be your moderator for this afternoon, but first, before we go to the pitches of the students, I would like to introduce to you our very independent jury. On the left, there's Janneke Hoekstra. She's the former director of the technical department at Han University of Applied Sciences. Second, we have Sander de Goede. He's a teacher in forensic investigation at the Police Academy and specialized in traffic accident investigation. And third, we have Reinier Rechter. He's working at PON, a well-respected partner, and he is manager service over there. So we have some different kind of people who will be evaluating you this afternoon. So I would like to point out that during the whole session, everyone here in this room and everyone at the live stream can send in their questions through our WhatsApp number, which is over here and which is on the bottom of the live stream. So please don't hesitate to ask questions to the students. I will receive them over here and I will try to translate them and ask the questions. If there are too many questions, we will send the answers to you later on by email. So, the jury will decide this afternoon who will get the ACE Student Award, who is the best student, but also who wins the fantastic prize of a Formula 1 Grand Prix travel to any place in Europe. So that's a fantastic prize, I think, and I'm hoping one of you will take me with you. Okay, so please let me introduce our first contestant, Mr. Dennis Laros. Come on, yes, thank you. Yeah. So, welcome, Dennis.
Thank you.
I already know you because you graduated at ACE. So, this must be exciting to be the first one?
Yes, a little bit, but I think it will be nice.
Okay, and who did you bring today?
I bring my mother today. During the Corona time I did most of my graduation at home. And I think my mother was nice to bring today over here. So.
A proud mother over there, so that's really nice, okay. And what grade did you get from the Fonds University of Applied Science for your graduation project?
7.6 was my grade for this graduation project.
So, an 8?
Yes.
Wow, very well done, very well done.
Thanks.
I also have a quote from your graduation teacher, Yvonne Kirkels. She's not here, but she is joining the live stream, so she should be hearing it. So I'm going to just read it because it's too difficult for me. Okay, Dennis is a professional, correct and calm person who, despite working from home, continued steady during this period and achieved good results. The fact that he wanted this broad strategic assignment at the intersection of technology, automotive and education also says he likes a challenge. Education and collaboration in the ecosystem were new subjects for him, which he mapped based on recent literature. Well done. So that's a nice compliment, I think.
It's nice to hear from her.
Okay. So, let's go and watch your pitch now.
Ik ben Dennis Laros. Mijn afstudeerbedrijf was ACE Mobility. ACE verbindt de automotive branche met de automotive hogescholen. Uit een eerder onderzoek uitgevoerd door KPMG kwamen 4 grote kansen voor de Nederlandse automotive branche. Mijn stagebedrijf ACE wilde daarin onderzocht hebben op welke punten ze hun partnerbedrijven verder kunnen adviseren. Eerst heb ik gekeken welke van de 4 kansen het meeste potentie had voor ACE. Hierbij is de laadinfrastructuur voor Nederland naar voren gekomen. En daarin ben ik verder gaan met onderzoeken hoe deze laadinfrastructuur in Nederland in elkaar zat. Daarbij heb ik eerst de externe omgeving onderzocht door middel van een D-step-analyse. En vervolgens ben ik dieper gaan kijken naar wat doen de verschillende partijen aan de aanleg van de EV-infrastructuur. Dat heb ik gedaan door verschillende stakeholder-analyses uit te voeren. Het belangrijkste resultaat is dat er verschillende kansen voor de Nederlandse automotive branche naar voren zijn gekomen. De 3 belangrijkste kansen waren hierbij het zonneladen van elektrische auto's, het snelladen van elektrische auto's en tot slot het draadloos laden van deze elektrische auto's. Hier dient nog veel ontwikkeling op plaats te vinden en de hogescholen kunnen door krachten te bundelen van verschillende opleidingen, zoals autotechnische kennis, maar ook ICT-kennis en bedrijfskundige kennis, deze kansen optimaal benutten voor mijn stagebedrijf. Het belangrijkste is wat ACE met mijn opdracht kan, is dat zij hun partners kunnen adviseren op welke punten zij door moeten ontwikkelen voor elektrisch laden. Ook kunnen zij op deze manier de hogescholen met relevante informatie voorzien, zodat het opleidingsaanbod op de hogescholen gelijk loopt met de vraag van de automotive branche. Ja, ik heb de opdracht als leuk ervaren. Door het corona ben ik natuurlijk niet bij veel partnerbedrijven kunnen komen, wat het toch een beetje raar maakt om de opdracht zo uit te voeren. Maar ik ben blij dat er een mooi resultaat voor mijn stagebedrijf uitgekomen is. En ik hoop dat ze de partnerbedrijven en hogescholen een goed advies kunnen geven door middel van mijn onderzoek.
So, very nicely done. Was a nice pitch. So, I'm not seeing any questions here right now. Jury, do you have any questions for Dennis regarding his research? Yes, Janneke, please.
Thank you for your presentation. I liked it very much. What you say is that the partners in the ecosystem should collaborate quite closely. Do you think that is already the case, or where do you see possibilities for improvement?
Yeah, for sure, automotive companies already collaborating with each other. But in my case, the collaboration between the universities of applied sciences and the automotive sector could be improved more. When it will be done, the education at the universities will be improved, and I think that's an important chance for the automotive industry.
Thank you. Is it a sufficient answer? Okay. Anyone else from the jury? Yes, Reinier?
Question. You make an advice for ACE, for their education program. I'm living in a business environment, in one of an importer and dealer company. Is there anything you can also hand over to the business environment in Holland, not just to ACE or the education?
In my report there were a few advices for the business environment as well, because ACE not only advises the universities but also his business partners. One of them is the development sections where the business partners could investigate in. So for example, there is a big chance in solar-based charging, and not only the University of Applied Sciences could answer that chance, but also the business partners could answer the chances pretty good. So.
Okay, thank you.
You have any questions? Yeah. Sander? Yes?
Dennis, thanks for your presentation. You mentioned different types of charging. What is your personal vision of what do you think has the future?
In my opinion, fast charging will be the biggest thing of future, because when a car could charge very fast, the other types of charging wouldn't be necessary. I think induction charging, so charging without cables, could be very easy for people at home, so they didn't have to charge their car by cable, but only drive them on a parking place, so the car will charge automatically. And solar charging is for the people who need to drive long distance. So in my opinion, when fast charging is very good implemented in the Netherlands, the other two types of charging wouldn't be that necessary, but more like a luxurious option on your car, so it makes charging a bit easier.
Okay. I think this question maybe from the live stream or from the audience, maybe a little bit answered already, but I'm just gonna ask it.
Okay.
It's gone. So I'm just gonna skip to the next question. A famous solar vehicle developer from Helmond and a big chemical company are working together. Is this a chance for the Dutch industry and ACE?
I think that will be a great chance for the Dutch industry as well. When ACE could translate this innovation to the universities could could change their lesson program, so they know the current developments at the industry, and I think that would be a great chance for ACE.
Okay. We will closely look at the development.
Yes.
Well, thank you so much, Dennis.
Okay.
You can go back to your seat.
Okay, thanks.
Okay, let's give a warm welcome to our second contestant, Rami Awad. So Rami, you graduated at Mitsubishi Turbocharger and Engine Europe.
Not yet. I still have to do my final presentation, so
When are you doing that?
I would like to keep that for myself.
Okay, okay. But somewhere in the coming up weeks, yeah.
Yes.
Okay.
Yes.
Very exciting. Okay. And who did you bring as a guest?
I brought my company supervisor. He's in the back, Rogier.
Oh, that's nice. That's nice.
Yes.
And your family is watching from home?
I think so. Yes.
Okay, great, great, great. So your graduation teacher Niels van Groningen also sent in a few words. So I would like to read this as well. So, I know Rami as a fairly introverted student who has always avoided public communication. During his studies, he also had a close group of friends that he could always fall back on. However, his graduation has demanded other qualities from him and has meant that he has had to take the lead more. He has grown strongly in his role by fully assuming responsibility for the success of his assignment and has developed a level of awareness in which the success of his research has become a personal issue. I think Rami outdid himself during his graduation, and I wouldn't be surprised if he continued to do this throughout his professional career. Wow, these are beautiful words,
Yes.
I think.
Yes.
Okay, let's watch your pitch.
Okay. My name is Rami Awad. Name of the company is Mitsubishi Turbocharger and Engine Europe, or MTE, produces turbochargers for passenger cars and diesel engines for maritime purposes and industrial purposes. So my assignment was to develop a digital measurement method for determining the strain and displacement of any object in 2D. So the purpose of the assignment was to develop a digital measurement system, which is called digital image correlation, to measure the deformation levels and the strain levels of any object in 2D. So mechanical measurement methods, like for example a strain gauge, have some major drawbacks. So for example, a strain gauge only has a limited measuring range, which allows only for the local strain to be measured. It also involves destructive alteration of the surface of the specimen, which will weaken the material and influences the test results. A strain gauge also has to be replaced every time after each test, and this of course will drive the cost up of the test when multiple specimens have to be tested. Mechanical measurement methods like a strain gauge have to be applied to the specimen surface, which will cause problems when the specimen is heated up to a temperature of 1000 degrees Celsius, which is also the working temperature of a turbocharger. So the increase in temperature will also cause the measurement method to increase in temperature as well, which will change the tolerances and the accuracy of the measurement method. The assignment was divided into 6 phases, wherein research was conducted, wherein the system was developed, it was also tested, and it was finally validated to see what the accuracy is of the system, and also to see what the precision is of the system and how reliable it is. So the result was a working system which is able to determine digitally what the strain and displacement are, if calibrated of course, in 2D. So MTE now has a system which was proven to be able to determine the strain of a 2D or flat object digitally, and the software of that system also has 3D analysis capabilities, which will be further explored and adapted by MTE so that they can use it to determine the strain and, with calibration, the displacement of any complex object, or in this case a turbocharger, during operation.
So, nicely done as well.
Thank you.
Okay, so are there any questions from our jury?
Rami, I'm wondering what is the biggest influence in your accuracy with this method?
So there are a few things. First, of course, you have a sensor, which is your camera system, and what determines accuracy is the resolution, of course, so how sharp the image is, and your color accuracy, because the software is dependent on the color contrast of your specimen. So if it can track those parameters correctly, you can also get a more accurate result.
Rami? I know there are a lot of very intelligent people working at Mitsubishi Turbocharger.
Yes.
And how come this makes you so unique to find this out?
Yes. So what we currently do to test how much our products deform is we apply strain gauges to it when testing. But these strain gauges have to be replaced after every test. So a strain gauge, for example, for this case is 7,000 euros, and it has to be replaced every time. So this product will allow Mitsubishi to have a method which they can use over and over again.
They were not able to find it out themselves? They needed you for that?
I suppose so, yes.
Okay, thank you.
Yes.
I didn't get completely whether you reached the goal that you set for yourself, and if you would continue this research, what would you add to it? Could you tell me that?
Yes, so the goal for this assignment was to make a system which is able to determine the deformation levels of any object in 2 dimensions.
Yes.
But as you all know, a turbocharger has many complex shapes. So
I know.
yeah, okay.
Yeah.
So I would add a second camera so that
Yes.
we can actually track the deformation levels of a turbocharger.
And are they going to use it?
Yes,
Your
definitely,
system.
definitely.
And could you make it even more accurate?
Yes. Part of it is hardware dependent, so the camera that you select for the setup, but the process of introducing contrast, so for example in the video by applying a paint pattern to the specimen can also help increase the accuracy.
Thank you.
Do you have any more questions, Jerry? I have 2 more questions from the audience. So question 1, what was the most difficult part during your graduation?
Yeah, it was definitely determining what the accuracy is, because it's a digital concept, so I had to recognize what I'm actually measuring, and that is the deformation in pixels.
So the defining was the hardest part, okay.
Yes.
And the second question is, how can you verify the optic strain measurement of the dimensions of the sample material itself?
What I did for this assignment was to use a reference method. So I used the extensometer, which was calibrated according to ISO specification, and I also used strain gauges. That's how I validated it.
Okay, thank you. Yeah, for me, it's I don't understand it, but I hope it's sufficient enough for our watchers. So, thank you so much, and you may sit down again. So, please welcome our third contestant, Lars van Kessel. Welcome.
Welcome.
What did you bring?
I did my research at Automotive trailers, and after my final presentation, I received this small model from the company.
As a gift?
Yes, as a gift.
It's very nice.
It was one of the trailers I have worked on. So.
Okay, this one. Okay.
No, I have multiple trailers in my tool, but it was one of them. So.
Nice.
It's really nice.
So this is your support.
Kind of.
And who did you bring today?
My girlfriend. So I did my research at home, and she saw not very much of it, but I talked a lot about it in the evening, and she don't fully understand it. So I hopefully today she understands it a little bit more. So.
Wow, this is your support, and hopefully today she'll get a better picture of what you've been doing all year, half a year. Yeah. Okay. Wow. So what grade did you get from the Han University of Applied Sciences?
An 8.6.
An 8.6?
Yes.
Wow, that's a 9.
Yeah.
Wow. Wow, that's very good.
No, I'm really happy with that. So.
Yeah, I can understand that. So, your graduation teacher, Tieme Kamerling, also sent in a few words. Lars van Kessel has been an ambitious, serious student who would like to put what he learns into practice. He has been a very pleasant, independent student in communication who functions perfectly as a full discussion partner. We wish all the students were like Lars. Pleasant to deal with, serious about his work, trying to set the bar as high as possible for himself. Lars is ready to go to work. So, are you going to work at Noteboom or?
No, I
Okay.
can't work with Noteboom. So.
Well, let's watch your pitch.
Mijn naam is Lars van Kessel. Ik heb mijn onderzoek uitgevoerd bij Noteboom Trailers. Noteboom is een bedrijf dat trailers ontwikkelt voor speciaal transport. Speciaal transport betekent vaak hoge en of asymmetrische zwaartepunten, waarbij een voertuig vaak uitzonderlijke manoeuvres maakt. Dit houdt in dat Noteboom eigenlijk een trailer ontwikkelt waarbij een fabrikant wil weten of een bepaald product op de Noteboom-trailer vervoerd kan worden van plek A naar plek B. Mijn afstudeeropdracht was het ontwikkelen van een theoretisch model om te bepalen of bepaalde producten vervoerd konden worden of niet. Dit model wordt gebruikt uiteindelijk om klanten beter te adviseren voor transportplannen. Ik heb de opdracht aangepakt door in het begin een plan van aanpak te maken. Hierin heb ik uiteengezet hoe ik het model ga opbouwen. En vervolgens heb ik een vereenvoudigd overhellend voertuigmodel gepakt, waarbij ik parameters steeds heb uitgebreid. En dus het optreden van wind, het oprijden van een berg, het rijden door een kombocht, dergelijke situaties heb ik toegevoegd in het model. Het resultaat is een theoretisch model dat in Microsoft Excel is ontwikkeld. Daarbij kan de trailer gespecificeerd worden, waarbij aan kan gegeven met wat voor een soort trailer we hebben te maken, hoeveel assen hebben we te maken, wat is de aslast, welke koppeldrukken hebben we, wat is het product dat we vervoeren, met wat voor massa heeft hij en wat is de hoogte van het zwaartepunt, zit de massa in het midden, zit hij erbuiten. Als dat allemaal is ingevuld, dan kan de theorie bepalen of een bepaald product vervoerd kan worden of niet. Noteboom gaat de opdracht allereerst gebruiken voor interne onderzoeken. Komen de praktijksituaties inderdaad overeen met de theorie van het model? En als dat het geval is, dan wordt het model eventueel aangevuld met de vereenvoudigingen. En kan het model in de toekomst gebruikt worden om klanten beter te adviseren over bepaalde transporten.
So, thank you. Well done. Jury, any questions?
Lars, your poster shows some graphs.
Yes.
Could you explain them?
Yeah, I have 3 triangles. A red triangle, that is the triangle that determines the maximum stability of the trailer. The orange triangle is a safety factor on the red triangle. It is not really it is not already specified what a safety factor is. There's more research for. And the blue triangle is the stability that the trailer needs. If the blue triangle is between the orange one, then for sure it can be transported. Is the blue triangle between the orange and the red triangle, then it is possible to transport, but it is really critical. And is the blue triangle bigger than the red triangle, then it's not possible to transport your product. That is what the graph shows.
Yes, Janneke?
Could you enlighten us a little bit on what are the important aspects of your model? Because that's
Which
not on the
parameter
page.
I have to put in?
Which model did you use, and what are the basic assumptions in that model?
I used a simplified tilting vehicle model that is built on lateral force and roll stiffness and some load, or some axle loads, and I have connected with some hydraulic scheme of a trailer. The front of the trailer is hydraulic connected with some axles, and the back of the trailer, the last axles are hydraulic separate from each other. So that have a kind of stability limit, and in the front the trailer of the axles can connected with each other. Then we have this is a completely hydraulic area of this with the same pressure, but it can also be separate, and then you have a different kind of stability limit. Then it will be more safe, but hopefully it's answering your question.
Lars, can you tell me more about the process you went through? When I looked at the poster in the preparation for this jury, I only saw 4 beautiful pictures of Notenboom trailers and the graphs, and nothing about your plan and the steps that you've been taking. Can you explain something about the process you went through?
In the first weeks, I have discussed with engineers at Notenboom all the parameters who have influence on the stability, such as cross rains, road slopes, like that. But also which parameters have influence from the trailer. So what delivers some counter moment due to the roll moment. And after that, I have developed the tool. But I did it at home because of the coronavirus. So it was really hard to do, but it is doable. But in the first few weeks, I have discussed with a lot of people what kind of parameters did influence the roll stability. And after that, I have developed my model step by step. This first one parameter, and after that, if it's correct, then the next parameter, and so on.
You were able to have discussions by phone or video conferencing?
Yes.
Working
I called my supervisor by phone, and if we don't come out it, then I go to Notenboom, and he also came to Notenboom, and then we have a short discussion for 1 hour or 2 hours, and then I come back to home. So.
Okay, thank you.
Yes, of course. Yeah, we're still running.
What kind of innovation did you bring to Notenboom? Because I can imagine that they've done these calculations before.
Yeah, they had some simple calculations, but I did it with more parameters. So the most important parameters was your suspension and your tires. That was already, but it was really simple. It was not accurate, and I did also the fifth wheel, the torsion and bending of the chassis, like that kind of parameters, and how long your vehicle of your trailer is. The bending will be much more, so that has a lot of influence, and that was not in previous calculations. So.
One final
Yeah,
question?
of course.
Do you know the 7-degree rule or the 2-degree rule?
What did you say? Sorry?
The 7-degree rule or the 2-degree rule, do you know them?
I don't know what you mean.
Well, I looked to the mammoet.com site, which also does heavy transport of those loads.
Yes.
And they have something called the dynamic stability rules.
I have something heard about it, but I'm not sure what it is.
I wonder whether you took that into your research as well, what the competition, for instance, does. Okay, thank you.
Thank you. Okay, I have 2 more questions from the audience. I don't know why, but why did you use Microsoft Excel, I think, instead of another?
It was one of the, how did you say, one of the requirements of it was one of the requirements for my project.
Okay.
Because other type of programs, such as MATLAB Simulink, was not available at Notenboom Trailer, so that's the reason I did it in Excel.
Okay, yeah, that's the easiest then.
Yeah.
Okay.
I had no choice.
No, it's a logical explanation. So the second question is, can the calculation model also be used to steer future active suspension?
I have some simplifications in my model, but if you extend it, so with some more steering wheel angles, it's possible.
It should be possible. Okay. Okay. Well.
It depends on what kind of trailer you have and what are the requirements of your trailer. So.
Yeah, that's not any question, so I'm just going to skip that. But if anyone has any more questions following up on this, please send them in, and we will answer them through email as promised. So thank you very much.
Thank you.
And take a seat. So, give a warm welcome to Pantelis Nicolaou. Almost. Thank you.
Yeah.
So you have such a beautiful name.
Pantelis Nicolaou.
Yeah, it's more of a, yeah, okay. I'm sorry, I don't have your rhythm. So, welcome. You graduated at Heister Yale?
Yes, but tomorrow is my defense day.
Yes, so you don't have a grade,
I don't have a
but
grade
you're
yet.
going to succeed.
Yes.
Okay, we're counting on that. And who did you bring today?
I brought with me my son Yanis.
A little bit closer to the microphone.
I brought with me my son Yanis. He's also a student for Automotive, so he's the next ACE
Oh,
nominee.
maybe he's the next winner of the A Student Award. So in what year is he?
First one. He just finished his proper dose.
Okay. And I think your family, the rest of your family is watching on the live stream, right?
Yes, the family by there.
That's very nice.
And
So,
some colleagues also.
And the colleagues as well, yeah. I have a nice message from Leo Buning for you.
Okay.
So he's your graduation teacher.
Yeah.
So
Supervisor.
I'm just going to read it. It's also very positive. If the results of the preparation for his measurements are not satisfactory, Pantelis takes matters into his own hands and does not shy away from using tools to obtain results far behind the decimal point. He's a smart student, a hard worker, and a broadly oriented student. He's involved with his fellow students and he has a good sense of humor. He's a true senior employee who is proud of his family. His son studies automotive engineering at the Han. I would really like to have him as a colleague.
Thank you.
That's a very big compliment. So let's just watch your pitch.
Yep. My name is Pantelis Nicolaou. Heister Yale Company is a world-class forklift truck manufacturer that designs, builds and distributes forklift trucks worldwide. I was born in 1964 in Athens, Greece. I came in the Netherlands to join with my love Maaike. First, I learned the Dutch language and refreshed my mathematics, and in 1991 I joined the automotive engineering at the Higher Technical School in Apeldoorn those days. In 1994 I graduated and started my career at Heister Yale in Nijmegen. In 2017 I joined the Master Education program as a part-time student. For the graduation, the assignment was given by Heister Yale Company. Heister Yale is developing a dynamic stability controller. For assessing stability, one needs to know the total lift truck's center of gravity very accurate. For what concerns the structural components, its COG is very well known to the manufacturer. For what concerns the center of gravity of the payload, this is because it varies in shapes, this is an unknown parameter. Currently, the controller assumes the payload center of gravity conservatively, which leads to a slower driving truck than actually the stability laws will allow, therefore a less productive truck. The assignment's objective was to find a way to determine the payload's COG position 50% more accurately and in real time. To tackle actually this challenge, I first did a literature research. During the research, it became clear that there was something missing. There was a gap. The researchers were assessing stability by assuming the payload center of gravity as being a known parameter. Therefore, this work contributes in filling this gap. The whole approach was based in first principles. First, a free body diagram was drawn from where the equations of motions were derived by applying Newton's second law. With that data, a mathematical model was created in Amasim, from where the center of gravity of the payload was able to be derived. The model required as input translational and rotational accelerations, as well as the tilt cylinder forces. For this reason, a test track was equipped with sensors to gather this data. The gathered data were fed back into the Amasim model, from where the horizontal center of gravity was able to be determined by 2 to 7% in accuracy, and the vertical center of gravity of the payload with 14 to 20% inaccuracy. For the mathematical model, an application for a patent will be filed and it will be used in the dynamic stability controller for the company. As a take-home message, the personal education is a lifelong learning journey that never stops.
So, thank you. If the jury has any questions, can you please step a little bit closer? Yes, thank you very much. Do you have any questions for Pantelis? Yes, Sander?
Pantelis, thanks for the presentation.
You're welcome.
You're saying this is necessary because then the trucks can move faster.
Yeah, that's correct.
So what kind of, how much time do you win with this system?
I haven't counted on that. The assignment was actually to have a 50% more accurate determination of the payload, but I haven't made any calculations for extra time winning.
Okay.
Yeah.
But do you know what kind of time that we're talking about?
Especially when the center of gravity moves up, it was very conservatively actually estimated, and my calculations actually will provide a more accurate center of gravity, meaning that the output of the controller will be more agile, and that means actually that the productivity of the truck will be increased, especially when the center of gravity is at those heights, yeah, because it will be more fast. Okay. Yeah.
How did you come at the idea that it should increase 50%? Is
It
that
was-
what you
it
thought
was a-
that is possible?
Yeah, it was a requirement, and I did first some manual calculations, and I found that it was possible. Yeah.
Okay. So your conclusion is that you succeeded?
The conclusion, you mean at that time or after I made the research?
After.
Yes. My conclusion is actually that I've succeeded. I met the objectives.
Yes.
Yes.
Thank you.
Yeah, one question regarding your poster. When I looked at the poster, it was quite, a lot of formulas.
That's true.
If you can't confuse them, was the first thing I thought. But when I looked at your presentation and your pitch, I'm very impressed. Why is it that your poster just shows some formulas and not the way you proceeded and how you came to this result?
Well, in the poster, I've used actually the method I've used, and this is actually based on first principles. And this is the reason I've also put it on the poster to make it more clear which method I've followed. That's why. Yeah.
Okay.
I don't know if it answers your question.
Well, I was quite wondering what steps you have been taken, which process you went through.
Okay.
But after the pitch, it was clear. But I just wondered why is not that on the poster? Why is not your way of working?
As long as you understand now the piece, yeah. Okay.
Yeah. Okay, but now it's clear. Thank you.
You're welcome.
So, anyone else? Okay, thank you. I have one question. Oh, but that was, again, what is the most difficult part of your graduation assignment? What was during the process, what was the most difficult?
The most difficult actually part, it was actually to find the time to combine this with my work, because it is a part-time actually education, so I have to find the time to work on that. But for the specific assignment, it was in the literature research I did in the beginning to find if there was something there, and there was not. So I have to find actually my way myself, how I will have to tackle this problem. So this is actually innovation.
Yes, and I know you're very, very modest, but I know you just invented this on your own. This
That's
is
true.
really new, but you can be proud of yourself, I think so.
Well, thank you.
So, will the system be better than an experienced operator, or does it give extra safety?
Well, when it comes to stability and safety, these are actually words that you have to really to weigh them by using them. Actually, the program for the control, it should be seen as a system that will give the right lessons to the driver how to treat the lift truck. It is not actually meant that to increase the hazardness, to be more, of the operation of the truck. It will guard, of course, for the stability, but the idea is actually to treat the driver as a student and then improve his actually skills by having this as a backup.
Okay.
Yeah.
So that's the main. The extra safety is not the main goal. Or
Yeah, the main goal was actually to increase the productivity of the truck. The system actually provides enough safety when the load is really located near the ground surface. But when it comes to a higher heights, then this will add to increase the productivity of the truck.
Okay.
Yes.
That's a nice effect. So are you going to continue this research to develop it even more at Hyster, or does
Yes,
it end
because
here?
at the end of July we have additional measurements. I used pressure sensors for measuring the tilt cylinder forces, and we will go on by using load cell pins that will actually measure forces without having the non-linear phenomena of stiction.
Okay.
Yeah.
So we will hear from that.
Yeah.
Again.
Yes, end of July I will have more results.
Okay. Keep us updated.
Yeah, I will.
Any more burning questions or? Okay.
Okay.
Well, thank you very much.
You're welcome.
Please have a seat. So now we're going to the last contestant, Pim Kempen. Hi there.
Hi.
Welcome. You graduated at VDL Enabling Transport Systems?
Yes.
Yes,
Solutions.
and sorry, solutions. Yeah, sorry, solutions. Oh, I'm so sorry. But okay, and what grade did you get from your graduation?
8 out of 10.
8. Okay,
Yes.
well, that is very nice.
Yes.
Okay, and who did you bring today? Also the same question for you.
Jan, my supervisor from VDL.
Okay, so he's watching you closely.
Yes.
Okay. Bas Gelijns also sent in a few words. So I will read them to you. Pim is a serious student. In semester 7, I got to know Pim better when he was on the smooth parking team. It already turned out that Pim is a hard worker and knows how to show perseverance. Pim is also active alongside the study. For example, Pim is a member in the organizational committee of the party tent for the Carnival of Sint Antonis. I thought that was a lovely detail. So when he graduated, Pim creatively avoided problems created by COVID-19 in order to yield a good result for his research. They would like to hire him at VDL ETS, but after the summer, Pim will start a follow-up study. So that's too bad for you. Okay, are you going to study at the TU Eindhoven?
Yes, I'm a pre-master.
Very good. Okay, so let's watch your pitch.
My name is Pim Kempen. I completed my thesis at VDL ETS. VDL focuses on research, development and testing of new concepts related to zero-emission mobility. LiDARs work by sending out laser beams and detect the reflections of those laser beams, and the SLAM technology works by scanning the route and placing landmarks in the route, and after driving the route again, recognize these landmarks. The goal of this project is to create an autonomous bus depot. When the system is implemented, the customers of VDL are able to get the bus depot automated, and research of a customer from VDL showed that an automated bus depot can save up to 10 FTE, and this will also save precious time because there is a short on bus drivers. VDL wanted a system which works without using transponders, and also a system which is able to localize itself without using GPSs, because in general those are expensive and inaccurate. This system is tested for the automated guided vehicles of VDL and also to test and if it's possible to implement this system in their public transport platform. In this project, we had to build a proof of concept and also design and perform initial testing, and the outcome of both would serve as a toll gate for VDL to decide if and how they would invest their future resources in the topic of autonomous driving. The project consists of 4 big steps, so learning the system, building a prototype, testing the prototype, and also simulate the difference between current and future VDL platforms. The results of this project are a working test platform, and also we did initial testing of localization and object detection. The results of those initial tests meet the KPIs which are set for this project. And also with this project we are able to get autonomous driving out of the specialist corner and create a bigger interest in this topic within VDL. The next step for this project is that we are going to intensify testing. So I'm happy to say I will stay at VDL for the summer and conduct the test I initially designed. And also we are going to determine the next steps for this project together with TNO. And the vehicle will be used to get customer feedback on the system. So overall I'm happy with the results, and I would like to thank everyone at VDL who took part of the project, and also I look forward to continue the project during the summer.
Thank you. Any questions from our jury?
Yes,
Janneke?
thank you for your presentation. You are continuing this summer. What is your aim at the end of this summer? What will you be presenting then?
So due to the coronavirus, we were not able to conduct all the tests that we wanted to test. So in the summer, I'm going to continue the tests. And you have to think like things like we were not able to get all the parameters set, which were influencing the system on like sensor performance, or maybe dynamic things on the vehicle behavior. So the system has to be dynamic on all those parameters, because we want to implement the system at every place, at every time. So rain, dark, inside, outside, those all have to be excluded and have to work on all those places.
Is a system like this already in use somewhere else, other brands, or in other parts of the world, for instance China or Mercedes or Volvo?
As I understood from the supplier, they are working with a big OEM on the automotive industry, and yes, I don't know where it's implemented else.
Does your research bring something as a competitive advantage to VDL, or to close the gap to the competition?
No, the system is used to test the basic principle of SLAM technology and LiDAR technology. So with this system we want to see if this works for the implementation we want to do, because we want to use it to get the automated bus depot working. And with this bus depot we have a business plan for our customers. So this will save precious time and cost. So that will help us in the end.
What is your personal opinion on automated driving? When do you expect to step on this automated bus?
In public road use, I don't know, but for this implementation, I think it will be a matter of years. Yeah.
Yeah, years, like 5 years,
No,
20
like
years, 30 years?
1 or 2 years, not like 5 or 10 years. So
Very nearby future.
I think so.
Okay. Yes, Janneke?
I'm surprised it isn't already there, because if you see at big flower markets, you see many automated vehicles going around. Why is this more difficult?
I think those work by using transponders in the infrastructure. And with this solution, there's no need for changing the infrastructure where it's driving.
Okay. Yes? No more questions from you? I have two. Not from me, but from the audience. Are there other vehicles that can benefit from this automated first or last mile system?
How do you mean?
Are there any other vehicles besides buses, or who can?
Yeah, the system is, it can be implemented in every vehicle, but we want to use it in buses.
Okay, but it can be implemented
everywhere.
everywhere.
What I said in the presentation, we are also testing the basic principles of the system to see if it's possible to implement it in the automated guided vehicles of VDL.
Okay. Well, very clear answer, I think. Another question, are you using rotating mechanical lidars or solid state lidars?
No, those are solid state.
Okay. I think that's a sufficient answer.
Yeah.
So, if there are no more questions from our jury, then I would like to thank you as well. And you can sit down now.
Thank you.
So, we're perfectly on schedule, I think. So this was our last contestant. The jury will now go away to discuss who is the winner. So they will come back in about half an hour. In the meantime, we have something else for you, but the jury may now leave. Thank you very much. You go to Rianne, yes. Okay, so in the meantime, we have a few videos of our students' teams, which we sponsor. We're very proud to sponsor 3 student teams who all focus on entering races regarding sustainable environment. So the Shell Eco Marathon and the Solar Challenge. We sponsored these 3 teams from the 3 universities, and we also created some videos with them. So first I would like to let you see the video of the ACE Solar Team Fontes. They are relatively new. They don't have a car or something driving just yet, but they are developing, and they're trying to focus on entering the World Solar Challenge next year or the year after that. So let's see this video. Thank you.
De World Solar Challenge, dat is een race in Australië waarin vele universiteitsteams van over heel de wereld meedoen om tegen elkaar te racen in een door hun gemaakte zonneauto. Gebruikelijk zijn dit allemaal universiteitsteams en wij willen graag als eerste HBO-team willen wij hier aan meedoen om te kunnen concurreren met de universiteitsteams en de gevestigde orde. Op het moment zitten we in de beginfase van het project. Dat betekent dat we bezig zijn met het ontwikkelen van een prototype. Wat wij waarschijnlijk willen gaan toepassen bij dat prototype is een zogenaamd catamaran design. Het is een design dat je wellicht bekend voorkomt van andere teams. Dat willen wij ook gaan gebruiken omdat het toch is gebleken dat het heel erg effectief is. Ook zijn wij van plan om het van carbon fiber te gaan maken. We zitten natuurlijk in de beginfase van het project en daarom kunnen we nog niet exact zeggen hoe de techniek er volledig uit komt te zien. Maar we kunnen wel vertellen waar we naartoe streven. Die auto die heeft zonnecellen op het dak. Daarmee laat hij continu een stel batterijen op. Die batterijen die worden gecontroleerd door een battery management system om ze optimaal te laten functioneren. Vervolgens zal deze batterij een naafmotor aandraaien die op een enkel achterwiel gemonteerd zal zitten. En dit zal onze auto aandrijven. Onze auto die zal 4 wielen hebben en wij streven ernaar om een eigen wielophanging te maken om deze wielen op te monteren. Ook zijn wij bezig om eventueel eigen luchtinlaten toe te passen. Nou, het design ziet er als volgt uit. Je hebt als het ware 2 zijspannen aan de zijkant met een vleugel in het midden. En in een van die zijspannen daar zal de coureur komen te zitten. De auto zal ongeveer 3,5 meter lang worden en 1,5 meter breed. Hoe zwaar die exact zal worden, dat is nog niet helemaal duidelijk. Dat weten we nog niet, maar we streven er natuurlijk naar om die auto zo licht mogelijk te maken Want dat kan hem uiteindelijk ook een stuk sneller maken en zuiniger. En dat is waar we naar streven. Als je hedendaags om je heen kijkt, dan zie je op de weg heel veel auto's die erg groot en zwaar zijn. Waar maar één persoon in rijdt, waarmee je soms wel 1500 kilo meeneemt. En een gigantische hoeveelheid aan ruimte. En dit laat natuurlijk een gigantische ecologische footprint achter. En wij laten eigenlijk zien met deze race dat het ook op een andere manier kan. Dat je op een CO2-neutrale manier toch heel effectief in staat kan zijn om mensen te vervoeren. En ik denk dat dat wel een grote invloed kan hebben op de industrie.
So, you cannot ask questions because this is not live, but if you have any questions or you would like to sponsor one of the teams, you can always contact us and then we'll contact you with them. So, let's go to the next video. It's from the Automotive team from the University of Applied Sciences. They finished third in the world in last year's race at the Shell Eco Marathon in London. So they did a very good job. Unfortunately, this year it's cancelled because of Corona, but hopefully next year they will do as good as they did last year. So let's watch their video.
I am Boas van der Hart. I'm the current team manager of the Automotive team. Together with 15 other students and 2 advisors, we are the Automotive team. And we are working on our own car that runs on hydrogen, the HM11. The HM11 is the 6th car in the 11-year history of the Automotive team, and it's the most efficient yet. It is race ready around 140 kilograms, excluding the driver, with a potential of 120 kilograms when we implement our new carbon fiber rims, our new seatbelt, carbon fiber firewall and carbon fiber wheel arches. Our car is approximately 1 meter high, 1 meter wide and over 3 meters long. The reason why the HM11 is so efficient is because for the construction we use lightweight materials such as carbon fiber, aluminium and 3D printed plastics. We use simulation models to create the aerodynamic shape and we have a fuel cell that best fits our application. These are the reasons why the HM11 is the most efficient car built by the Automotive team so far. The techniques used in the HM11 are very difficult, but they're relatively easy to explain. Just as in any ordinary car, it has 4 wheels, a steering wheel, brake, handbrakes and a horn. But the powertrain, or the so-called beating part of the car, is a bit different. We have the fuel tank, and there's no normal petrol or diesel in it, but compressed hydrogen. This hydrogen flows towards the fuel cell. And this is where the magic happens. The hydrogen is in the fuel cell split into electricity and the rest products, which is water and oxygen. The electricity is then stored in a small battery pack and then transferred to the electric motors that power the wheels. So what makes our car and our team so special? We differentiate to most other student teams is that we are a part-time team. That means that this project is implemented in the university's curriculum. We get 2 days allocated a week to work on a project and the remaining 3 days we are expected to be in our lessons. Unlike most other student teams, where they're working full-time on the car. Despite the lack of time we have, we are still able to keep up with our competition. Hydrogen has a great potential for the mobility industry. When produced with renewable sources, it's a green energy carrier. Hydrogen is the solution in the overshoot in produced electricity on sunny and windy days, as the electricity can be converted into hydrogen. And when the electricity is needed, the hydrogen can be converted back into electricity. For the automotive industry, hydrogen is still patiently waiting for their breakthrough. The infrastructure is not ready for a vast amount of fuel cell electric vehicles. It's not the question whether hydrogen is going to play a big role in the automotive industry, but when will it?
So this is a totally different challenge. But we also have Team Philippides, which is the student team at Rotterdam, University of Applied Science. They also attend the Shell Eco Marathon. So let's go to their movie right now.
My name is William Terwocht. Our team name is Team Philippides. Our team consists out of 5 studies, the biggest part of that being automotive engineering. It's around 40 to 45 people divided over 2 cars, one of which is the Triga 3 right behind me. It is a 3-wheeler that participates in the prototype class of the Shell Eco Marathon. The second car is the Quadriga 3, which is a car that will compete in the urban concept class of the Shell Eco Marathon. It is a 4-wheeler, battery electric driven, and will be built after the summer. The Triga 3 is a 3-wheeler, 1 driven wheel on the backside and 2 steering on the front. It's formed like a bullet, so it's as aerodynamically as possible. It's driven by hydrogen, which means that there's a small hydrogen tank in the back of the car, which converts hydrogen into electricity to drive the rear wheels. The Quadriga 3 has a battery electric powertrain, which means that a battery up front powers the 2 motors in the rear through a motor controller to power the vehicle, and the chassis where it's all bolted on and the body is also bolted on is made out of thermoplastic composite. The reason why the Quadriga 3 is special is because it has a thermoplastic composite chassis. It's super stiff and really light, but the problem with thermoplastic composite is that it's really difficult to post-process it after it's already been formed into a shape, which is something that we've been trying to work around in the last year to get that to work, so we can have a thermoplastic composite chassis at the next race. What the automotive sector will benefit from our findings during the engineering and designing and building of the Quadriga 3 is the use of the thermoplastic composite as a part of a chassis. As far as we know, it's never been used before in a different part in the automotive sector. The automotive sector can use this knowledge that we have gained over the last year for maybe use in engineering of other car chassis. What also makes our car different from the rest with the Quadriga 3 is it has a carbon fiber with rubber laminated leaf spring in the front and rear. The rubber breaks the shocks and the carbon acts as a spring so that most of the vibrations in the chassis are picked up and eliminated by the suspension.
So I hope you enjoyed these videos. We're ahead of schedule, far ahead, and we still have some time. The jury needs some time to discuss who's the winner. So we're going to take a break, a 10-minute break. Exactly at 4:50 we'll be back, but we have to give them some time. And please stay and watch, please stay logged in, because the exciting part is now coming. So see you in a few minutes. So, welcome back all. As you can see, there's still no jury because the decision is very hard. They need some more time. They need 5 more minutes. So we will be back at the, 5 more minutes, I said 5. Okay, at exactly 5 o'clock, we will come back with the results. But the jury is fan of all of you. So, hope you stay tuned in and see you in 10 minutes. Bye-bye. So, welcome back. As you can see, our jury returned, so I'm guessing they made a decision. Please, don't let us wait any longer. Janneke, will you please tell us which student won and why?
Yes, well, you will understand, dear students, that we had a very hard time. It was very nice to see your posters and especially also to hear all the presentations. And we were impressed about what you had done in this time, which is a bit extra difficult because of Corona. You probably had to do a lot at home, and we thought that you had very good and very nice results. And therefore we had a hard time. And we took a lot of different things into account when coming to our conclusion. But I will first say a bit more about the 5 graduation works. Dennis, what we like particularly in your work is that it is very useful for the future of ACE. I think that we can really do something, and we think that applicability of the research is important. Lars, we were impressed by the many parameters that were in the model. What was not a simple model. It maybe looked a bit simple, but when you explained to us all the different facts that you had to take into account, we were very impressed. Pantelis, we thought your research was of a high level. It really is filling in a gap, and that is shown in the fact that it will become a patent, and we thought that very good, and also your presentation very good. Pim had an excellent poster with a very applicable result, which we liked a lot because applicability is one of the things that we counted most in coming to our conclusion. And Rami also had a very good and nice poster, high level of research and applicable results, and that we also liked a lot. Have I spoken to all of you? Yes. Well, we had a very close finish. That's why we needed some extra time to get to our conclusion. And what we took into account is, as I said before, the applicability, of course, the results as such. How innovative is it? The quality of the poster, the quality of the presentation, whether you really answered the questions that we posed, that you were given, and well, we would like to have more than one award, but alas, there is only one winner. There is just one winner. The prize is not too bad to go to a Grand Prix together with somebody else, and with flight and hotel. Finally, we had to make a decision, and the prize goes to Rami Awad.
Wow! Woohoo! Come on up. Okay. This is nice.
Oh, can I stand up?
Yes, you can give
stand up. I can give it to you. It's 1.5 meters, of course. Thank you.
So this is our winner. Yes. We're going for some drinks now, but I will close the stream. Now I would like to thank all of you for being here and all of the over 75 people watching the live stream for being here and showing an interest in this event. We will post an after movie on our socials and on our website, so please like and share. Thank you very much. Oh, en de jury bedanken we nu. En de jury bedanken we nu. Ja, of niet? Ja, deze is voor Rami? Deze is voor Rami. Nou, gefeliciteerd. We kunnen niet kussen, maar van harte.
Hartstikke bedankt.
En er komen nog meer cadeautjes aan, ook voor de jury uiteraard.
Heeft Niels afgesproken dat je hem mee moest nemen naar de... Nee, hij heeft er niks over gezegd. Nee?
Nou, na dat commentaar niet, dus.